Hi, this is Algebra 1, Module 4, Lesson 4, the practice problems. We're going to go through these and make sure you're on the right track with them. First, we're going to write an equation from a context, and we'll pay attention to see if there's any inequalities going on with any of these different ones they're giving us. So we're going to write the equation. This should be review, and then answer the question that is asked. So Virginia's painting service charges $10 per job. I'm going to go ahead and make some notes on here. It's $10 per job and 20 cents per square foot. And what if she earned $50 for painting one job? How many square feet did she paint at the job? So to put this into an equation, let's see. If it's $10 for every job she does, so when I show up, it's going to be 10 bucks. So that's a $10. And then I'm going to do 20 cents per square foot. So what's going to repeat in there during one job? Square feet. I'm going to have more than one square foot that I'm going to paint, but the jobs aren't going to repeat because each job, I have to paint multiple square feet. So it's going to be the 0.20x. And if we're testing out to see what it does with a specific job, we're going to put equals 50. Equals 50. Okay, so there's my equation. $10, notice I had to put this as 20 cents. So $10 to show up, 20 cents for every square foot, and a specific job was $50 total. So now I need to solve this for x. So my first step is going to be subtracting 10 from both sides, right? So then I have 0.20x equals $40. So we got to take out that initial payment of $10. And if I take 40 divided by 0.2, 20 cents. Now keep in mind it's dividing by a decimal, which means we're going to get a much bigger number than 40, and that will be 200. So x equals 200 feet squared, which makes sense. You're going to need 5 feet just to even get $1. And if he earned $50, he's got to do more than lots more than 5 feet, a lot more than 40. All right, next one. Renting the ice skating rink for a party costs $200 plus $4 per person. Kind of uses some math vocab for us. If the final charge for Dane's birthday party was $324, how many people attended the party? Well, let's do our equation first. It costs $200 just to even show up, right? So that's our starting point. And then if it's $4 per person, multiple people are going to be there. That's the equation piece. And we particularly want to know when the cost was $324, how many people did we have? So let's go ahead and solve this. So first I got to take out that initial 200. So then I end up with 4x equals 324 minus 200 is 124. And if I have a times 4, I need to divide by 4. So x equals, looks like 31 people. Okay, so that's just our basic equations, solving for x. We've been doing that. All right, indicate if the following statements are true or false. Explain your thinking. So the notion that 12 is less than x means the same thing as x is less than 12. Kind of works like an equal sign. You can have probably 3 plus 5 equals 5, or 3 plus 5 equals 5 plus 3. You can kind of rearrange it, right? Is that true or not? No, unfortunately, it is not. This is false because this symbol means less than, and this, yep, symbol, the greater than symbol, means greater than, and those are different. Okay, inequality, -2 parentheses x plus 10 parentheses is greater than or equal to 75 says the same thing as basically distributing out -2 times x plus -20 is greater than or equal to 75. So I can multiply the -2 on the left side without reversing the inequality. Remember how we said if we multiply by negatives, that throws off things? What do you think? Well, in this case, we only multiplied by the negative on the left side. We were just simplifying. We didn't actually do it to both sides. So this is true. We only distributed the -2 to one side. So the other wasn't affected. As long as only one side's affected, then we've actually kept it true. We just simplified. We didn't actually solve anything. All right, 5. When solving the inequality, 10x plus 22 is less than 2, the second step should say 10x is greater than -20 because I added -22 to both sides, so you get a negative number on the right. So here's the key word in this one, added -22 to both sides. Does adding a negative make a difference when you're with inequalities? It does not. So this is false. Adding negatives to both sides doesn't reverse the inequality. Just like when we were practicing it in that one practice problems, the adding and subtracting to both sides didn't make any difference. If you're taking down, if you're adding -22, both are lowering by 22. That still keeps the left side smaller than the right side. Because when solving the inequality, -5x is greater than or equal to 45, the answer is x is less than -9, because if I divided both sides of the equality by a negative number. This one is true. So it was when you were multiplying or dividing by the negative that it throws it off, right? Because we can even test this. Multiplying by a -9 would turn this positive and make it equal. But if I multiply by a -10, which is smaller than -9, I have a positive 50. That keeps it greater than 45. So true. Dividing both sides by a negative makes the reversal sign reversal necessary. We need to have that switch because I can't use a positive number and have it and then make it equal to that. The words that describe the inequality x is greater than or equal to 100 are x is greater than or equal to 100. So I basically just said that same thing, right, when I was reading it. So that is true. They said the words for the symbol correctly. All right, so hopefully that makes sense. We're kind of starting to see some rules now for these inequalities. Next, we want to solve these inequalities. Verify that the answer is part of the solution or not. So, going to show our work. Let's get that out of there. So for this one, We are going to start with getting rid of the minus 9. So that's a plus 9. So 2x equals 3 plus 9 is 12. If I divide by 2, oh, not equals, less than. Make sure we put the right symbol in there. Got to get used to that. Less than. Divide by 2, those cancel. So x is less than 12. So, or sorry, not 12, 6. We just said that. Okay, so can it be equal to 6 with this symbol? No. So that is not part of the solution set. Let's do this next one. Okay, so it's saying -5, possibly our answers. Let's see. Okay, so I want to subtract 25 since I'm trying to get that x by itself. Those cancel. And 13 minus 25 is a -12. So 4x equals -12. Not equals, my goodness. Is greater than 12. So I need to divide both sides by 4. X is greater than -3. All right. So if x has to be greater than -3, is -5 part of the solution? Can I put -5 in there and have it work? Nope. -5 is less than -3. So that one doesn't count. Okay, for 10, 6x plus 4, or sorry, 6x minus 4 is less than or equal to -28. Now, first we got to plus 4 to both sides. So 6x less than or equal to, remember this time, -28 plus 4 is -24, which means if I divide by 6, x is less than or equal to -4. So is -10 less than or equal to -4? Yes, it is. So that would be part of the solution. And one more. 3x instead of -5, let's plus 5. Those cancel. So I have 3x is greater than or equal to, well, -5 plus 5 is 0, actually. If I divide by 3, x has to be greater than or equal to 0. So is 1 greater than or equal to 0? Yes. All right. Good to go. Solve each inequality and graph the solution on a number line. So to solve this, let's just keep going with the pattern we have. Instead of a plus 9, we need to minus 9. So x, 7 minus 9, is less than or equal to -2. So I'm going to go over here to -2. It's less than or equal to, so I can put a dot. Less than means I go to the left. Next one. Okay, plus 4, -3x is greater than 2 plus 4, I can't even read my writing there, is 6. So if I divide it by a -3, what did we just say had to happen when we divide by negatives? Going to have to flip that sign. So instead of x is greater than, x is less than -2. And let's just make sure this works. So I'm going to pick a number that's less than -2, do -3, and see what happens. -3 times a -3 is a +9. +9 minus 4 is 5. Is 5 greater than 2? Yes. So I know that I've picked the right direction. It is less than, so I need to have an open circle, and it's going to the left. Next one. 3x is less than -6. Divide by 3. So x is less than -2. So I got that one again. And I can double check. 3 times a -3 is -9. Is that less than -6? Yes. So I'm open circle at -2, and I'm going to the less. Keep going. All right. X divided by 5 is greater than -3/10. Opposite of divide by 5 is times 5. Those cancel. X is greater than 15 divided by 10, which is really like 1.5, right? So it's greater than. So I'm going to look for 1.5 on here. So put a circle kind of at that. It's a little close to the 1. Let's go 1.5 right here in the middle. And it's greater than. So I'm going to go this direction. All right, here's another negative. Dividing by a negative 10. Dividing by a negative 10. Those cancel. Now I have x instead of greater than, let's do less than. And look at that. We have the 15, negative 15. So just to make sure, I'm going to put in a negative 20. Negative 20 times negative 10 is positive 200. That is bigger than 150. So I'm correct in going with the less than. So open circle on 15, x is less than. And last one of these. I have a divide by negative 7, so I need to times by negative 7. And if it's a negative, I need to switch this symbol. So negative times a negative is a positive 35. So just to make sure, I'm going to do, let's see, what's a number that's smaller than 35 but divisible by 7? Let's do 28. So I'm going to do 28 divided by negative 7. That is negative 4. Is negative 4 bigger than negative 5? It is. So I've done correctly by switching my symbol. So because it's equal to, I'm going to go 1, 2, 3, 4, 5. Symbol there, and then I'm going to draw my arrow. Okay, so when in doubt, do I switch it or not? Always plug in a number to double check. Okay, solve each multi-step inequality. Okay, I'm going to use some of the space down below. I think I'm going to need it. All right, so I need the numbers on one side, the x's on the other. So let's add 5 to both sides. Those cancel. X is greater than 2x plus 8. I need to subtract 2x now. Those cancel. 1 minus 2 is negative. Oh, what am I not drawing? Negative. Okay, we do a text box. Negative x. Uh-oh, lost my ability to write. Well, let's do a text box then. Negative x is then greater than 8, right? And so if I have a negative over here, I actually need to switch my sign, because if I'm dividing by a negative 1 to both sides, then that means I'm dividing by a negative. So x would be less than negative 8. So again, just to double check, if I do a negative 10, negative 10 minus 5, negative 10 minus 5 is negative 15. Negative 20 plus 3 is negative 18. So negative 5 is bigger than negative, oh, not plus 3, 17, negative 17. So always fill those in to try to see. I don't know why I can't draw. This is going to cause problems. So x is less than negative 8. So over here on the next one, see if it lets me do it now. Okay, so now we want to try to get x by itself. So I'm going to multiply both sides by 12. Since they're both why this isn't drawing for me. Um, since 12 is bigger than 3, I'm going to multiply both by 12. So times 12 times 12. Those cancel. That actually cancels to make a 4, right? So now I have 3x minus 4 is less than or equal to, because I've multiplied by a positive, 2x times 4, which is really 8x. Now I'm going to divide both sides by 3. So I can get that parentheses out of there. So x minus 4 equals 8/3 x. It's kind of an ugly number. Well, let's subtract an x from both sides. And you know what? Because we have the 8/3, let's not divide by 3 first. Let's distribute. Changed my mind. Let's go ahead and distribute because that might make this a little bit not as ugly. So if I distribute my 3, I have 3x minus 12 is less than or equal to 8x. That works a little bit better, doesn't it? So now I can subtract 3x minus 3x. Those cancel. Negative 12 is less than or equal to 5x. And to get this one by itself, divide by 5. Those cancel. So negative 12 over 5, which we could do out as, what is it, 2.4? I think it's being 2.4 is x. So either one of those can work, negative on there for that one. All right. And this next one, we'll go ahead and distribute again first because 3 divided by 2 and we got other stuff going on. So let's just do 2x minus 6 less than or equal to 3x minus 2. So let's add 2 to each side. So I have 2x minus 4 less than or equal to 3x. Those cancel. So now I can subtract 2x from each side. I have my negative 4 is less than or equal to, x, right there. Didn't have to do much else after that. All right, let's scroll down. See if I can get this to work for my last few. All right, so last ones. We have to solve the systems of equations, and we actually want to use substitution for this. So for example, we can look at this first one. Since we know y equals 5, I can just substitute the 5 in for y. So I can put negative x plus 5 equals 1 and solve from there. Minus 5 minus 5. Negative x equals negative 4. If I cancel both of my negatives out, x equals 4. So 4 is my x coordinate. That works. And now I can substitute 4 in for here. So negative 4 plus y, which is 5. Does that get me 1? Let's get my y value. What's my y value? Oh, 5. Duh. Y is 5, no matter what. Okay, so trying with this one. So instead of 5 times x, we're going to put 5 times 8 plus 2y equals 0. And we're going to solve for y this time. So 40 plus 2y equals 0. Let's subtract our 40 from each side. So 2y equals negative 40. And if I divide both sides by 2, y equals negative 20, which means my coordinate is 8, because x equals 8, comma, negative 20. So these are actually my answers for this, because it says solve the system of equations. So we want to actually solve it for a coordinate where they cross. All right, so 23. Let's look at this one. 2y equals 10. So that means y must equal 5, right? If I divide both sides by 2. So if I'm going to do 4x minus 2 times 5 equals 50. 4x minus 10 equals 50. I'm going to add 10 to both sides. So I have 4x equals 60 now, right? I added 10, divide by 4, x equals 15. Well, if x equals 15, put it in here. We said y equals 5, right? So it must be 15 comma 5. For 24, 3x equals 12. So x must equal 4, right? 12 divided by 3 is 4. So instead of a x, I'm going to put in a 4. 4 times 4 minus y equals 5. 16 minus y equals 5. So minus 16 minus 16, negative y equals negative 11, which means I can cancel out both of my negatives, dividing by negative 1. So x equals 4, y equals 11. So here's my answers for those two. Let's do the last one. Well, we ended up doing everything on these, didn't we? So now we got to substitute. Let's solve for, oh, look at that. They both equal y. So instead of putting y equals, I'm just going to write 2x minus 5. That's what one of the y equals. And it has to equal the other y, right? X plus 8. If they both equal y, they should equal each other. So if I add 5 to both sides, 2x equals x plus 13. Oh, I shouldn't have crossed those out. Minus x, x equals 13, right? I'm left with 1x. So if x equals 13, well, 13 plus 8 is 21. So my coordinate must be 13 comma 21. All right, let's do my last one. 3x equals 9. Well, x must equal 3 if 3 of them equal 9. So now I can plug in a 3 for x. 5 times 3 plus y equals negative 5. 15 plus y equals negative 5. Oh, 5, not 15. Minus 15, minus 15. Y equals negative 20. And I know x equals 3, so my coordinates must be 3 comma negative 20. So that's how we're doing that, solving by substitution. Hey, thanks for joining us today, and we'll see you next time.